There are 4 marbles on a table, and each marble is a different color. Red, green, blue, and yellow. 2 marbles are selected from the table at random and put in a bag. Is the order of the marbles or the order of their colors important? So does it matter if you choose yellow then blue or blue then yellow? No, you're putting them in a bag. It doesn't matter which one was chosen first. You're kind of choosing them at the same time. So, well, the answer is no. It doesn't matter. And here's what I was talking about before. The term permutation means arrangement, and order does matter. The term combination means selection, and order does not matter. In word problems, it's up to you to determine if the context of a problem requires an arrangement, which is a permutation, or a selection, which is a combination. I'm going to show you how to do both. We already did the permutations. We'll look at some combinations, but eventually you're going to have to decide, is this a permutation or is this a combination? And the way that you're going to decide is to think about, does it matter what order the objects are chosen in? And if the order is important, then it's a permutation. If the order is not important, then it's a combination. Use a tree diagram to find the number of unique color combinations for the 2 marbles. So we could choose a red marble or a green or a blue or a yellow. If we chose red first, then we could choose green next, or blue or yellow. If we chose green first, then we could choose not a red, right? Because we already have that red-green possibility. So we could choose blue or yellow. If we chose blue, well, blue-red is already up there. Blue-green is already up there, so it's just blue-yellow. Oh, and then we don't have that. So there are only 6 possibilities. Instead of, if you were looking at it as a permutation, there would be a lot more. Only 6 possibilities. And then it asks us to use combination notation to find the number of unique color combinations. So you probably saw this on your calculator already, the NCR. You have NPR for permutations, NCR for combinations. Usually we call this choose. Remember the P, we say like 3 pick 2. If it's a C, we'd say 3 choose 2. So N is the number of items in the set, and R is the number of items to be selected. If we're looking at this marble question, there were 4 marbles on the table, and we're going to choose 2 of them. 4 choose 2. And if you do that on your calculator, you find at the same place you find the permutations, it's just below it, and that works out to 6. How many ways can 3 or 4 marbles be chosen? So this is one where you have to look at different cases, right? You get 3 marbles or 4. So 3 would be 4 choose 3 plus 4 choose 4. What do you think 4 choose 4 is equal to? So 5. 5 ways in total. Here's another situation. It says there are 5 toppings available for a pizza: mushrooms, onions, pineapple, spinach, and tomatoes. If a pizza is ordered with 3 toppings and no topping may be repeated, how many different pizzas can be created? Why is this considered a combination? Doesn't matter which order you put the stuff on in, right? Although some people might argue. Cheese is always first. I think that's a given because the cheese isn't even one of the options. But yeah, some people would argue that the order that you put stuff on a pizza does matter. But when you order a pizza, you don't even know what order they're going to put things on, right? You just tell them what you want on it.
This is the truth.
All right, so how many different pizzas can be created? So it said there's going to be 3 toppings and none can be repeated. So there were 5 toppings to choose from, and you're going to choose 3 of them. So 5 choose 3. That's all there is to that question, which is equal to 10. This one says combinations with repetitions not allowed, same as before, but sample sets with subdivisions. So how many 6-person committees can be formed from 11 men and 9 women if 3 men and 3 women must be on the committee? What do you think? 3 men and 3 women. So if we choose the men first, there are 11 men and we're choosing 3 of them. When we choose the women, there are 9 women and we're choosing 3 of them. And what goes in the middle in here? A multiplication, right? Because you're not choosing men or women, you're choosing men and women. And that's a multiplication instead of an addition. I think this is going to be a big number. 13,860 different committees could be formed. So this is a continuation of the combinations lesson from yesterday. A committee of 5 people is to be formed from a selection pool of 12 people. If Carmen must be on the committee, how many unique committees can be formed? So we already know that Carmen is going to be on the committee for some reason. And we need 5 people in total out of 12. How many unique committees can be formed? So really, what do you have to choose?
11 choose 4.
Yeah, you have to choose 4 people out of 11 because one of those people already is automatically chosen. So it's just going to be 11 choose 4. Which is 330. 330 different committees could be formed. So the second part says, a committee of 6 people is to be formed from a selection pool of 11 people. If Grant and Helen must be on the committee, but Aaron must not be on the committee, how many unique committees can be formed? So for this one, you had 11 people. You need to choose 6, but 2 are already chosen, right? So you're actually choosing 4. And out of the 11, you already took the 2 that are chosen and the one guy that they said, this guy can't be on the committee. So there are only 8 people left to choose from for those 4. 8 choose 4. Here's the next question. Have a look at that. How many 5-letter words using letters from triangle can be made if the 5-letter word must have 2 vowels and 3 consonants? This is a tricky question because it actually involves permutations and combinations. Permutations because it's talking about how many 5-letter words, and words are different based on how you arrange the letters, right? So it's an arrangement of 5 letters. But we have to look at, it says it must have 2 vowels and 3 consonants. So we have to choose which vowels and consonants we're using, make a selection of letters, and then look at arranging them into words. So if we look at choosing the letters first, how many vowels are there to choose from? 3. So we're going to do 3, choose 2, because we want 2 vowels. And then choose the consonants.
5 choose 3.
5 choose 3. That's just deciding which 5 letters to use. Now we need to look at how many ways we can arrange them. So choose the vowels and choose the consonants and arrange them. So how do we arrange those 5 letters that we've now chosen? 5 factorial or 5 pick 5? And that works out to 3,600. This is an at least at most thing with a combination. So it says a committee of 5 people is to be formed from a group of 4 men and 5 women. How many committees can be formed if at least 3 women are on the committee? So a committee of 5 people, when we're talking committee, order doesn't matter, right? It's still a combination. But we need to look at all of the different cases. Remember we did those cases with permutations as well when we had at least at most? The different cases here would be, we could have 3 women and 2 men, right? Or, what are the other possibilities? Because it says at least 3 women. We could have 3 women and 2 men. Or we could have 4 women and 1 man. And I guess those are the only possibilities, right? No, there's one more. What's the other one? Or all 5 women. So, let's look at choosing these committees. So if we're going to do the 3 women, 2 men, it's 5 choose 3 multiplied by 4 choose 2. Does that seem right? There are 5 women, choose 3 of them. There are 4 men, choose 2 of them. And we're choosing women and men, so it's multiplication. But then we say or 4 women and 1 man. What's the or mathematically? That's a plus. So that would be 5 choose 4 times 4 choose 1. Or, so another plus, 5 choose 5. That comes out to 81 possible committees.